Today we're going to work on Module 3, Lesson 10, and we're going to start by putting just a few notes in your math journal so that you'll have a good resource to look back at. So Module 3, Lesson 10, title is Writing and Interpreting Inequality Statements Involving Rational Numbers. So we're going to look at some inequality signs and symbols, which are greater than and less than are the symbols that we're going to be working with today. So a less than symbol, keeping in mind that the alligator wants to eat the larger number, if that's an easy way to think of it. So the number on this side would be less than the number on this side. This is your greater than sign. This is less than or equal to, and this is greater than or equal to. So when you see the top of the equals sign and then the inequality sign below it. So a statement you might be given is order the rational numbers from least to greatest. Remembering that rational numbers are fractions, decimals, positive, negative, any of those numbers. And we're going to order them from least to greatest. So if I had 5 1/2, 2 and 3, so obviously all positive, and I want to order them from least to greatest. And I'm going to do that using the signs, the inequality signs. So I would say 2 is less than 3 is less than 5 1/2. So we're ordering just like we've been doing the last 2 days, but instead of putting a comma between to list the numbers as we order them, we're putting inequality signs. So again, this would say 2 is less than 3 is less than 5 1/2. If I had to do it from greatest to least, then it would look like this. 5 1/2 is greater than 3 is greater than 2. So that would change the way my list would look and what sign I would use. So some things to remember. Use the correct symbol in between each rational number to show the value. So you're thinking about using whether you need less than or greater than, depending on whether you're listing your numbers least to greatest or greatest to least. So again, remember that you're going to use this less than sign for least to greatest, and you're going to use the greater than sign if you're numbering from greatest to least. So once you've completed the notes, then we'll start working on the lesson, and it's Lesson 10. Lesson 10 is page 95 of your book. So you'll want to turn your book to page 95 when you finish the notes. We're going to start with the opening exercise. Just kind of read through and write the integers or rational numbers that would go in there. So the opening exercise says, the amount of money I have in my pocket is less than $5 but greater than $4. So we know that if you have less than 5 but greater than 4, an example that you might have, let's say maybe you have $4.75. That's just an example of what you could have. B says, write an inequality statement comparing the possible value of the money in my pocket to $4. So if I have $4.75 in my pocket, then if I want to compare those, I would say $4 is less than $4.75. Then I have to write an inequality statement comparing the possible value of the money in my pocket to $5 for letter C. So I know that $4.75 is less than $5. So my inequality statement would look like this. $4.75 is less than $5. Exercise 1. Graph your answer from the opening exercise on the number line below. Also graph the associated points with 4 and 5 on the number line. Explain in words how the location of the 3 numbers on the number line supports the inequality statements you wrote in the opening exercise, parts B and C. Write one inequality statement that shows the relationship among all 3 numbers. So we're just going to use this number line to show what we did in the classwork. So the first thing that we're going to do is kind of think about what we would want to show. Well, we know that we want to show 4 and we want to show 5. So we're going to put a 4 and a 5. So keep in mind, on a number line, you're not always having to put a 0. Sometimes you can have a number line that just goes between 2 numbers, and this one's going to go between 4 and 5. So if I think about how many spaces or segments I have in between, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would think between 4 and 5, I have 10. I have tenths is what I'm thinking of, between the 4 and the 5 if I'm looking at decimals. So if this is my 4 and this is my 5, then I know that this would be 4 and 1 tenths, 4 and 2 tenths, 4 and 3 tenths, 4 and 4 tenths, 4 and 5 tenths, 4 and 6 tenths, 4 and 7 tenths. And I know that $4.75 is going to be between 4 and 7 tenths and 4 and 8 tenths. So it's going to go about right here. So I also have to write one inequality statement that shows the relationship among all three numbers, and that would look like this. 4 is less than $4.75, which is less than 5. So I'm just putting those three numbers together to make an inequality statement. 4 is less than $4.75, which is less than 5. On the next page, example 1, again, they're going to give us a list of three numbers, and we are going to write one inequality statement to show the relationship among the following shoe sizes. So these are shoe sizes, 10 and 1/2, 8 and 9. And notice they're asking us first to list from least to greatest, and then to list from greatest to least. So keeping in mind that least to greatest is that less than sign, and greatest to least is that greater than sign. So I know by looking easily at these numbers that my least is 8, and then I would have 9, and then I would have 10 and 1/2. So I'm first going to list them and just leave some space between them for my sign. So I would say 8 is less than 9 is less than 10 and 1/2. Okay? Greatest to least, I know it's going to be opposite order, so 10 and 1/2 is my greatest. I'm going to leave room for my sign. 9 would go here, and 8 would go here. So now I'm listing greatest to least. I need that greater than sign. 10 and 1/2 is greater than 9 is greater than 8. Example 2, we're going to have to look at a table and kind of interpret some data. Mary is comparing the rainfall totals for May, June, and July. The data is reflected in the table below. Fill in the blanks below to create inequality statements that compare the changes in total rainfall for each month, the rightmost column of the table. So notice there's several columns of our table. We have month, May, June, July. We have this year's total rainfall in inches, last year's total rainfall in inches, and then this last column, changes in total rainfall from last year to this year. So this is the column that we're wanting to use. We're not going to order these numbers, we're going to order these numbers. You also might notice we have a negative number we have a rational number that's negative in our list as well. So it says write one inequality to order the changes in total rainfall. So first I'm doing from least to greatest. So if I'm looking at just these numbers, obviously my least is going to be that negative number. So I'm going to put negative 1 and 4 tenths. I'm going to leave space. If I look at 3 tenths and 5 tenths, in my ones, so when you're always lining up decimals when you're comparing them, in my ones I have a 0, but in my tenths there's a 3 and a 5. I know a 5 is a larger number than a 3. So if I'm going least to greatest, 3 tenths and then 5 tenths. And least to greatest, I know my signs are less than signs. So if I'm doing greatest to least, then I am switching the order of the numbers I just did. So I'm going to put 5 tenths, 3 tenths, negative 1 and 4 tenths. And then I need to think about my sign. I know greatest to least, I want my greater than sign. 5 tenths is greater than 3 tenths, and 3 tenths is greater than negative 1 and 4 tenths. It says, in this case, does the greatest number indicate the greatest change in rainfall? So in other words, my 5 tenths is my greatest number. Does that indicate the greatest change in rainfall? And it doesn't, because if we think about it, a negative 1 and 4 tenths means that the rainfall has changed over an inch in May. So that's actually the greatest change in rainfall, even though it's not the greatest number. So we would say no, the greatest change in rainfall was in May, since the total rainfall went down by 1 and 4 tenths inches. Next, we're going to look at exercises 5 through 8, and we'll do a few of those just to have some real-world examples. So we're going to start with exercise 5. Mark's favorite football team lost yards on 2 back-to-back plays. They lost 3 yards on the first play. They lost 1 yard on the second play. Write an inequality statement using integers to compare the forward progress made on each play. So I'm first going to look at my wording so I know whether they're positive or negative and what numbers that I'm going to need to list. So they lost 3 yards and then they lost 1 yard. Well, we all know that if you're losing yards in football, it's definitely a negative thing. So to say that they lost 3 yards is a -3, and to say that they lost 1 yard is a -1. So I'm going to say -3 is less than -1. So meaning they lost more yards, right? It's further negative. So we want to think about distance from 0. Okay, so that's how we would write that. -3 is less than -1. Number 6, Sierra had to pay the school for 2 textbooks that she lost. One textbook cost $55 and the other cost $75. Her mother wrote 2 separate checks for each expense. Write 2 integers that represent the change to her mother's checking account balance. Then write an inequality statement that shows the relationship between these 2 numbers. So I know that if something costs, right, if the mother's writing a check, that's money that's taken out of her bank account. So those are both also negative. Notice it said integers because we don't have a decimal or a fraction. So we have 55 and 75. So the 2 integers that I have are -55 and -75. So now I have to think about the order of those. The one that's the farthest from 0 would be my least number, right? And the one that's closest to 0 would be my greatest number. So one way I could write these is -55 is greater than -75. -55 would be closer to 0. Number 7, Jason ordered the numbers -70, -18, and -18 and 5/10 from least to greatest by writing the following statement. -18 is less than, -18 and 5/10 is less than -70. Is this a true statement? Explain. Well, when we look at this, we should know right away this is not a true statement because I want the number that's the farthest from 0 to the left on the number line to be my least number, which is that -70. If you think about how we would number our number line, so even if you made a small number line and did a 0 and I said, oh, -1, -2, -3, I know that if I continue going, -70 is going to be much farther down the number line than -18 or -18 and 5/10. So we know that this is not true. The way that these should be ordered is -70 is less than -18 and 5/10 is less than -18. So this is what Jason should have done. So we would say no, not true. And our explanation is our inequality statement right here that shows how Jason should have done it. After you've completed this, turn to page 103. We're not going to do 8 or 9 of the exercises, but I would like you to turn to page 103 in your book, which is the problem set. And I'm going to have you do a few of these. We'll do one together, and then I'm going to have you do a couple on your own, and then raise your hand. So you may want to use your word list in your math journal for this as well, because it gives you some, when you're looking at the wording, it may help you figure out positive and negative. So number 1 we'll do together. It says 7 feet below sea level is farther below sea level than 4 1/2 feet below sea level. So they're not asking us whether that's true or not. They're giving a statement. We have to write an inequality that relates the rational numbers. So I have to think about what numbers they're talking about. Well, I know that 7 feet below sea level is going to look like a -7, right? I know that 4 1/2 feet below sea level is going to look like a -4 1/2. So when I'm comparing these 2 numbers, I know that -7 is going to be farther from 0 on the number line. So I'm going to put -7 is less than. It's farther down. -7 is less than -4 1/2. So I would like for you to do 2, number 3. So again, reading and just comparing the 2 numbers. 4 and 5. So numbers 2, 3, 4, and 5, and again, it gives you 2 numbers to compare. Make sure you pay attention to your wording. Actually, number 5 gives you 3 numbers to compare. So 2, 3, and 4, you have 2 numbers. Number 5, you have 3 numbers. You're writing the inequality statements. Look back at your notes. You can raise your hand if you need help. When you finish, raise your hand and I'll check over your work.